Okay, again we're looking at the law of sines, the ambiguous case, or side-side angle, given two sides and one angle. I'm Jody DeVoe, and we're going to look at, this time, the two-triangle case. Okay, this time our problem is A equals 11, B equals 18, and alpha equals 26 degrees. I note that there are two sides given and only one angle. The fact that there's only one angle given tells me that I'm in the ambiguous case. There could be two triangles, or no triangles for that matter, or just one. Okay, so the fact that there's one angle given tells me ambiguous case, side, side, angle. Okay, it tells me I have to check. Okay, as I said in the previous pencast, in the one triangle case, there are ways to do this differently. One way is to look at the table and memorize a set of facts, a test to see whether you're going to have one or two angles or no triangles before you even get started. My preferred way, because I'm just not real big into memorizing stuff, is just to do it and do the triangle, solve the triangle, and see, are there two angles and therefore two triangles possible or not. And that's why I'm going to go ahead and do this. So again, I'm going to draw this triangle, and the triangle again is just kind of more to help me see what is opposite of what, not in any way for accuracy. So I have alpha equals 26, so the side opposite alpha has to be A, which is 11. I'll call this side over here 18 for B, and then that makes this angle in here beta, and this angle up here gamma. And again, alpha, beta, gamma. Okay, so I'm going to go ahead and solve. I'm going to say the sine of 26 degrees and the side opposite that is 11. And then I have to solve for angle beta next, because I don't know anything about side C or angle gamma. So I have sine of beta over the side opposite that is 18. Okay, so when I solve for the sine of beta, then I get sine beta equals 18 sine 26 degrees. We're in degree mode. Remember to put your calculator in degree mode, over 11. When I solve for that, I say the sine of beta equals 0.72. Okay, 0.72. Okay, so this is where the ambiguous case happens. This is what makes it possible, because when I have to hit this inverse sine button on the calculator, the calculator gives me one answer to that, but there's actually an infinite number of angles where the sine of that angle is 0.72. The calculator gives me one. There's infinite solutions to this. And the good news is, I guess, is that I don't really have to consider all solutions. I just have to consider two. Okay, the calculator gives me one. I have to consider the second one. Let me just draw you this picture again, in case you're kind of forgetting why there's an infinite number of solutions to this. Here's your sine function, kind of wandering back and forth around the x-axis here. And 0.72, let's call that 0.72. What you're trying to do is figure out where this line intersects the curve. And as you can see, there's an infinite number of places where it does intersect. This first one comes from the calculator. So that one comes from the calculator when you hit the inverse sine button. But all the rest of them you have to find yourself. The way that you find the second one, so to find the second solution, you always take 180 degrees minus the one from the calculator, the one that comes from the calculator. Okay, so I'm going to hit the calculator. I'm going to find that the inverse sine of 0.72 using the calculator is 46 degrees. The other possibility, the second possibility, there's actually an infinite number of other possibilities. The second one, though, is 180 degrees minus 46 degrees, or 134 degrees. Okay, so these are my first two solutions to this equation. The sine of beta equals 0.72. There's infinite number of more. We're just going to consider these first two. So what we're going to do is we're going to check for these two cases of beta, are there two triangles possible? Okay, so I'm going to check. All right, so one possibility is if beta equals 46 degrees. So if that's the case, if beta equals 46 degrees, then alpha is still 26 degrees. Beta, as we said, is 46 degrees. And then to find gamma, I'm going to add these two together because we know that the sum has to add up to 180. Because the sum of the angles inside of a triangle add up to 180. So if I add alpha and beta together, I get 72 degrees. So that tells me then I have 72 degrees so far. To get to 180, I'm going to take 180 minus 72, which leaves for gamma 108 degrees, so that now alpha plus beta plus gamma all add up to 180 degrees. Again, alpha plus beta plus gamma add up to 180 degrees. Okay, so that's one possibility. Everything looks good, alpha, beta, gamma, and then I would have to solve for side C. So then solve for side C. And we'll go back and do that. Let's check though, is there a second triangle? Is there a second triangle? Okay, well, let's see. Our other possibility was, if you recall back up here, beta also could have been 134 degrees because, as we said, there's many places where the sine of beta is equal to 0.72. The one the calculator gives me, that 46 degrees, is only one of those possibilities. Another possibility comes from 180 degrees minus whatever the calculator gives us. In this case, it was 46 degrees. So another case for beta could be 134. So let's check out that. If beta equals 134 degrees, then can I still have another triangle there? So let's check. Alpha is 26 degrees, that's given. Beta could be 134 degrees because that's another place where the sine of beta is 0.72. And then I have gamma. Is it possible this time to have another angle in there that would fit in the triangle? So let's check. I have alpha plus beta because they have to sum up to 180 degrees. All the angles in the triangle have to add up to 180. So if I add 26 and 134, I get 160 degrees. And in this case, there is room left over for that gamma. If alpha and beta add up to 160, then gamma could be 20 degrees to get me up to that 180. So it's very possible then that alpha is 26, beta is 134, and gamma is 20 degrees, and that gives me the second triangle. That is possible. So yes, a second triangle is possible. Okay. As we saw in that first example, the one where there was only one triangle possible, if you recall, what happened is when we checked this, alpha plus beta turned out to be a number that was bigger than 180 degrees. So there really wasn't any room left for gamma to fit into a triangle. But in this case, it was less than 180 degrees, the sum of alpha plus beta. So there was plenty of room left over for the gamma angle to be 20 degrees. And so now I have a second triangle that's possible, and now I have to again solve for side C. Then solve for side C. Okay, so let's go ahead and look at those two cases. So triangle 1. Okay, in triangle 1, we have alpha is 26 degrees, beta is 46 degrees, and gamma we found in that case was 108 degrees. We know that A is 11, B is 18. Still have to solve for side C. Okay, I'm going to go back to the given values of alpha and A instead of using the calculated values of beta. So I'm going to say the sine of 26 degrees over 11 equals the sine of 108 degrees divided by side C. And then I'm going to solve for C. Let's see, that's going to give me C equals 11 sine of 108 degrees over the sine of 26 degrees. And when I get done pushing my buttons, I'll find that C is equal to 24. Okay, so that's one triangle. Second triangle, what we found for this one was that alpha was 26 degrees. Beta this time, let's see, was 134 degrees, which led us to gamma, so that they all add up to 180 degrees inside the triangle. Left gamma with 20 degrees. Okay, and A is 11, B is 18, solving for C. Again, I'm going to go back to the given values instead of using the calculated values from beta. That compounds our error when we do that, our calculation rounding errors. So I say the sine of 26 degrees over 11 equals, this time the sine of 134 degrees. Oops, sorry, that's incorrect. That should be, I'm using gamma this time. So that should be equal to the sine of 20 degrees over side C. Okay, so solving for side C this time gives me 11 times the sine of 20 divided by the sine of 26. And we'll do some button pushing again. 11 times the sine of 20 divided by the sine of 26 gives me 8.6 for C. Okay, so those are my two solutions, two triangles in this case. And again, the reason why I even had to consider two triangles to see it, to check if there's two triangles, was because I had to hit that inverse sine button. The reason why I had to hit the inverse sine button is because they only gave me one angle and two sides. So one angle, two sides, you hit the inverse sine button, you got to check. Do I have another triangle? Do I only have one triangle? Or it could be that there's no triangles, and that's the final case we'll look at.